Let's do a couple more problems involving the chain rule. Now, the tricky part in calculus when you are differentiating functions is to figure out which rules to use, because sometimes you have to use more than one. So there's the power rule, the constant rule, the product rule, the quotient rule, the derivative of the ln of x, the derivative of e to the x, and now the chain rule. And so what happens is you kind of have to combine everything together. So it's sometimes nice when you're learning, when you get to the chain rule, to state which rule you need to use. So I'm looking at y is equal to x squared times 2x minus 5 cubed. So because these are being times, I know that I'm going to have to use the product rule. So the first thing I notice here is that I'm going to have to apply the product rule, which is the derivative of the first function times the second plus the first times the derivative of the second. So I have that the first is x squared. Well, the derivative of that is easy. I just need to use the power rule. I bring down the 2, subtract 1 from the top. And then the second is going to give me 2x minus 5 cubed. But now I need to use the chain rule for this derivative because it's a composition of function where the inside is 2x minus 5, right? So the u is 2x minus 5. So that means that s prime is going to be bring down the 3, don't touch the inside, subtract 1 from the top, times u prime. So when I put that together, it's going to be 3, 2x minus 5 squared, times the derivative of 2x minus 5 is 2. So more appropriately, I'll write 6, 2x minus 5 squared. So then when I apply the product rule, so I had the chain rule inside the product rule. And I even have the power rule that I had to apply. So I have y prime is going to be 2x times s, which is 2x minus 5 cubed, plus the first one, x squared, times 6, 2x minus 5 squared. Okay, now I need to factor. So let's take a look. First, right, I'm separated by a plus, so I'll underline the red one, and I'll underline the blue one, and I'll look at what is common in the red and what is common in the blue. So let's first look at the coefficients. I have a 2 and I have a 6. So that's a 2 will be common. Then I have an x to the first power and an x squared. So just one x is common. And then I have 2x minus 5 cubed and 2x minus 5 squared. So that's common to both is the squared. Okay, let's look at what I have left over. So I'll put a plus here. So in the red one, I took out the 2, that's gone. I took out the x, that's gone. And I took out 2x minus 5. I took out 2x's minus 5. So I still have one 2x minus 5 left because I originally had 3 of them. Then in the blue, I took out a 2, so I'll be left with a 3 out of the 6. I took out an x from x squared, so I'll be left with x. And I took out the whole 2x minus 5 squared. So I'm going to have y prime is equal to 2x times 2x minus 5 squared. And in the parentheses here, I can combine 2x and 3x for 5x minus 5. So actually, I can take out even more, a 5. And when I took out a 5, that's going to become a 10x, 2x minus 5 squared times x minus 1. And here's my derivative. Okay, let's do another one. I have 5x squared times ln of 3x minus 1. So again, one more time. I have 5x squared times ln of 3x minus 1. So I'm going to have to use the product rule. So I'm going to have that the first function is 5x squared, which means that the derivative of the first is 10x. Then the second function is the ln of 3x minus 1. So remember that when you take the derivative of the ln of u, it's going to be 1 over u times u prime. So that means that s prime, the derivative of 3x minus 1 is 3, so it's going to be 3 over 3x minus 1. So I had to use the chain rule for this one because it wasn't just the ln of x, it was the ln of 3x minus 1, so the interior function was 3x minus 1. So then when I apply the product rule, I'm going to get y prime is equal to 10x. Again, you can still do the little cross if it is still helpful to you, times the ln of 3x minus 1 plus 5x squared times 3 over 3x minus 1. Okay, let's see if I can factor out anything. So I have my red, my first one. I have my blue, my second one. So I have a 10 and a 5, which means I can factor out a 5. I have an x and an x squared, which means I can factor out an x. Now what you want to be careful is this ln and this 3x minus 1, they're one unit. So I can't factor out a 3x minus 1 because first of all, the second one is in the denominator and the other one is in the ln. So this is the only thing I can factor. So let's look at my leftovers. In the first one, I'll be left with 2 ln 3x minus 1. And the second one, I'll be left with an x here. So I'll combine it as 3x over 3x minus 1. And there's nothing I can do with this, so this is a perfectly fine answer. Let's do another one. So I have y is equal to x minus 1 to the 5th, x minus 1 divided by 3 minus x to the 5th. Okay, so the first thing I need to notice is the outside function is to the 5th power. The interior function is x minus 1 over 3 minus x. So actually first I need to use the chain rule. All right, which is the specific chain rule is the general power rule, right? So if I have y is equal u to the 5th, that means that y prime will be 5u to the 4th times u prime. So my u is x minus 1 over 3 minus x. But to find the derivative of this, I need the quotient rule. So I have a quotient rule inside of a chain rule. So I'm going to find the derivative of u by using the quotient rule. The top is x minus 1, which means that the top prime is 1. The bottom is 3 minus x, which means at the bottom here, and be careful, it's negative 1, right? Because it's 3 minus x. So I didn't need any chain rule to find those. I just needed the power rule. And then when I apply that, I'm going to get u prime. And I'll write the formula again. So it's t prime b minus tb prime divided by b squared. So t prime is going to be 1 times 3 minus x minus 1 times a negative 1 all over 3 minus x squared. So at the top, I'm going to have 3 minus x, and here I'll have a minus minus, which actually becomes a positive, so it doesn't change the second part. But the x's cancel, and I'm left with 3 minus 1, which is going to give me 2 times 3 minus x squared. Now that is just u prime. So I got to go back. So I have y prime is equal to 5, my u, which is x minus 1 over 3 minus x to the 4th, times 2 over 3 minus x squared. So I can combine the 5 and the 2, which will give me 10. Now this 4 means I have 4x minus 1s and 4 1 over 3 minus x. So I can actually split this up, because what I can do is I can combine the 3 minus x, the 4 of them and the 2 of them, into 6 of them. And here's my y prime. Okay, perfect. Let's look at another one, a common question that we've seen before. So we have find the values of x where the tangent line to the graph is horizontal. So I'm going to have to find the derivative and set the derivative equal to 0, because when the tangent line is horizontal, the instantaneous rate of change is 0, the slope is 0, the derivative is 0. So let me take my function out here. F of x is equal to 3x plus 1 to the 4th times 2x minus 1 to the 5th. Okay, first thing I need to notice is 3x plus 1 to the 4th and 2x minus 1 to the 5th are being multiplied, so I'm going to have to apply the product rule, where my first function is 3x plus 1 to the 4th. My second function is 2x minus 1 to the 5th. But both of these require the chain rule to find the derivative. They use the general power rule, which is a specific type of chain rule, And how we apply that is that we bring down the 4, we do not touch the inside, we subtract 1 from the top, and then we multiply by the derivative of the inside, which will give me 3. And this will simplify to 12, 3x plus 1 cubed. I do the same thing for the derivative of the second function. I bring down the 5, I don't touch the inside, I subtract 1 from the top, and I multiply by the derivative of the inside, which will give me 2. And so this is going to give me 10, 2x minus 1 to the 4th. Okay, beautiful. Now let's apply the product rule. So I have f prime of x is going to equal to the derivative of the first, which is 12, 3x plus 1 cubed, times the second, which was 2x minus 1 to the 5th, plus the first one, 3x plus 1 to the 4th, times 10, 2x minus 1 to the 4th. All right, I need to factor this. So I got my red, I got my blue, and I look at what's common to both. So first I have a 12 and a 10, right? I always look at the number first, just to look at the coefficient, and the common factor between 12 and 10 is just 2, unfortunately. Okay, then I look at the 3x plus 1. I have 3x plus 1 in the red, and I have 3x plus 1 in the blue. So I can only take out what's common, which will be the smaller amount, which is 3. Then I look at the 2x minus 1. I have 5 of them in the red. I have 4 of them in the blue, which means I have 4 of them. That's common. And then you look at the leftovers. Okay, in the red, I took out a 2 from 12. That will give me 6. So 6. I took out all 3 of these. And then I took out 4 out of 5, so it leaves me 1. So I have 6 times 2x minus 1. Okay, in the blue, I took out 2 from the 10, so that will give me 5. I took out 3 out of 4 of the 3x minus 1, so that will give me this. And then I took out all the 2x minus 1s. So this is going to give me 2 times 3x plus 1 cubed times 2x minus 1 to the 4th. All right, let's see what kind of goodies I got here. This will give me 12x minus 6, and this will give me 15x plus 5. So I can combine that to 27x, plus 5, minus 1. Yes, 27x minus 1. Perfect. Okay, and this is why now you see that it's really important to learn how to factor properly, because I'm now setting this equal to 0, and I could not solve for that unless it was factored. So what you do is you set each factor equal to 0. That's the zero product property. So you have either 3x plus 1 is equal to 0, 2x minus 1 is equal to 0, or 27 minus x minus 1 is equal to 0. And so this is going to give me x is equal to negative 1/3. This is going to give me x is equal to 1/2. And this will give me that x is equal to 1 over 27. So you have 3 places in your graph where the tangent line is horizontal.